everyone, it's Justin again. In this lesson, we're going to be using what you've learned about area so far in this unit to calculate the area of figures that don't look like any of the standard shapes that we have area formulas for. By the end of this lesson, you will be able to find the area of a composite figure that is made up of any combination of rectangles, triangles, parallelograms, trapezoids, circles, and sectors. First, we'll discuss what composite figures are and how to find their area. Then, we'll complete 2 example problems. So I've been using the phrase composite figures a lot. Do you have a guess as to what that means? Composite means made up of multiple pieces put together. So, composite figures are just polygons that are created by putting multiple standard shapes together. When considering calculations with composite figures, it's helpful to think about what those standard shapes are that have been combined to create it. For example, if I want to know the area of this polygon here, well, that's not something that I have an area formula for. Do you have a prediction for what I might be able to do to find the area of this strange figure? Did you notice that this composite figure is just made up of triangles and rectangles? I definitely know how to find the area of these smaller shapes. So, to find the area of a composite figure, you just want to break it up into standard shapes that we can find the area of, like rectangles, triangles, parallelograms, trapezoids, circles, and sectors. Then you can find the area of each smaller shape and just combine their areas to get the total area of the whole composite figure. There are often many ways that a composite figure can be broken down into standard shapes. In fact, can you think of another way to break up this one? Maybe you noticed that I could have used trapezoids in some of these places, like this. Or maybe you shifted around the boundaries a little and used these shapes instead. All of these would work just fine, and there are probably still others that I just haven't noticed. Before we jump into practice, I do want to point out something more important. For this lesson, you can assume that if a figure looks a certain way, then it is. For example, we can assume that this is a right angle and that all 3 of these segments are perfectly horizontal and parallel without having to have the symbols in the original picture. Now that we've got that cleared up, let's try this out. Our first example problem tells us to find the area of the composite figure. We want to start this by breaking up the composite figure into standard shapes that we can find the area of. Pause the video now and break up this figure. There are many ways you can break up this figure. You could use 1 rectangle and 1 trapezoid, or 2 rectangles and a trapezoid, or 2 rectangles and a triangle, or anything else you can find. I am always going to choose to show you the method that involves the least number of individual shapes. So I'm going to be using the 1 rectangle and 1 trapezoid breakdown. No matter what method you use, you will still get the same final answer, so feel free to use another method if that visually makes more sense to you. So, the area of this whole figure will be the area of my rectangle plus the area of my trapezoid. Let's start with the rectangle. Pause the video now and find the area of this rectangle here. To find the area of a rectangle, I'm going to need its base and height. The base is this entire long side, so that's 23 centimeters. The height is this short side, so that's 5 centimeters. If you had these sides the opposite way, that would also be correct, since any side of a rectangle can be the base, and the height will just be its perpendicular side. We can now multiply those together to get an area of 115 square centimeters for the rectangle. I'm going to put that number up here so I don't lose track of it while we work on the trapezoid. Speaking of trapezoid, why don't you go ahead and pause the video now and find the area of it. To find the area of the trapezoid, I'm going to need base 1, base 2, and the height. This one's a bit more complex. The bases are the two parallel sides. I can see that one base is 2 centimeters, but I wasn't given the length for this base. Do you have any ideas on how I can find it? Well, since the right side of this composite figure is a rectangle, I know that this whole segment here is congruent to this one, making it 23 centimeters. I know that this top portion is 7 centimeters, so what's left as the length of our base, the remaining portion? 23 minus 7 leaves 16 centimeters as the length of my other base. Next, I'm going to need the height. We can assume that anything that looks perpendicular is perpendicular, so this segment here is my height. But what is that length? Can you see a way to find the length of this segment? Well, this whole segment has a length of 12 centimeters. And from this top piece, I can see that this portion of the segment is 5 centimeters. So how much is left for the height? 12 minus 5 leaves 7 centimeters as the length of the height. Now that I have all of the segment lengths that I need, I can substitute them into the area formula for trapezoids, simplify that, and see that the area of this trapezoid is 63 square centimeters. So what else do I need to do to get my final answer? Yes, I just need to add my rectangle area to my trapezoid area to get a total area of the composite figure. So what does this give me? Did you say 178 square centimeters? Nice job. This is our final answer for this problem. If you chose to use a different breakdown of shapes to solve this problem, you should still have gotten 178 square centimeters as your final answer. Let's do one more example together. This problem asks us to find the area of this composite figure rounded to the nearest tenth. Now, this figure is a little bit different because it has a piece cut out of it. Do you have a prediction about how we can handle this cutout piece? Did you predict that we're going to wind up subtracting the area of that cutout in the end? Let's look closer at how we can break down this composite figure to see what that will look like. Pause the video now to break up this figure, including the cutout. Like the last example, there are a few ways that the shape can be broken up. You could make it one trapezoid, one rectangle, and a half circle cut out. You could shift those a bit to make a different trapezoid and rectangle with the half circle cut out. Or you can break up that trapezoid into a rectangle and a triangle. I'm going to be using this configuration of a trapezoid, rectangle, and the half circle cut out. How do you think we'll combine the area of these three shapes to make the area of the full composite figure? Yeah, we're going to add the rectangle area plus the trapezoid area, but since that would give me this shape, I'm then going to need to subtract the half circle to account for that cutout. So, we need to find the area of the trapezoid, rectangle, and the half circle. Pause the video and find these three areas now. Check your work against mine as I go through them. Let's start with the rectangle. The rectangle has a base of 6 feet and a height of 17 feet. Remember, it doesn't matter which side is the base and which is the height, so if you have these backwards, that's okay too. Now I can use these in the area formula, simplify that, and get an area of 102 square feet for the rectangle. Next, I'm going to do the trapezoid. One base of the trapezoid is this entire segment that goes across the 12-foot section and the 6-foot section. So that gives me a base length of 18 feet. The other base is this segment here, which is identical to this 12-foot section. We can trust our eyes here and say that the other base is 12 feet. The height is going to be this segment here, which I don't have a length for yet. But this entire segment is going to be 17 feet to match the segment across from it. And since this top portion is 9 feet, what does that leave for the length of this segment, our height? Right, 8 feet. So now that I have both bases and the height, I can calculate that the area of this trapezoid is 120 square feet. Last is that half circle cutout. If we want to consider this a sector, then the central angle would be 180 degrees, giving us an area formula that looks like this. Or, if you'd rather simplify, we can just say that the area of the half circle is 1/2 times the area of the whole circle. Either way, we're going to need the radius of the circle in order to calculate the area of it. If I imagine the entire circle that this comes from, I can see that this length of 6 feet is congruent to the segment up here, which represents the diameter, which means the radius is going to be half of that, so 3 feet. Now I can substitute that into my equation and simplify it to get an area of 4.5 pi square feet. I'm going to wait until the very end of this problem to calculate this with the approximation to pi to prevent any errors due to rounding. At this point, I can come back to the expression that we created for the area of the whole composite figure. I'm going to bring down the operations that we set up, and then I'll put this expression into my calculator to get the decimal approximation. What is our final answer here? Your calculator should have given you this decimal approximation, which rounds to a final answer of 207.9 square feet. When it comes to finding the area of composite figures, you should break up the whole figure into multiple standard shapes that we have area formulas for. Then you can find the area of all of the smaller pieces and combine them to get the total area. Be careful about how you combine the areas of the smaller standard shapes. Be on the lookout for any cutout sections that will need to be subtracted from the total area instead of added. See you next time!